So we're back at Tecnau, and Pete's going to run us through the Revolution 50 StreamFolder book processing solution. So Pete, what are we looking at?
Yeah, so this is kind of a reintroduced solution for us using the Revolution 50 cutting platform. We've been in the plow folding, stream folding, book block solution business for quite a while, but this uses our kind of flagship Revolution 50 product line with a lot of changes to stream folding. It also adds the ability for us to tack glue the book blocks together. So yeah, let's run through it. So it'll do anything from a 2-up, a 3-up, or a 4-up in position on the web, through inline plow folding, rotary cutting, jogging, tack gluing, and then on the end we've also got a robot that's actually taking the stacks out and putting them on a pallet, all without an operator intervention.
That'd be fun to see.
Yeah.
And is there a maximum thickness to the block?
No, we can actually stack up to about 8 inches tall, so more than any binder would be able to bind. So the stacks of book blocks are actually composed of multiple books in the stack, and the books are glued together within each book, but not glued together between each book. So very easy for the operator to separate, or we can do automatic destacking, and I'll show you kind of how that would work when we get down to the stacker.
Okay.
So this is the Revolution 50 unwind. This is what unwinds the roll at high speed into the StreamFolder 5152 book block solution. As we come out of the unwinder, we have a dynamic web aligner that's actually using either one of 2 sensors to monitor the position of the edge of the web. And if that sensor sees the web move away from it, this is a steering unit that'll actually steer the web back to the sensor. And the reason that's so critical on this line is because we need that web to be tracking completely straight as we come up into the infeed of the F50 StreamFolder, because we're actually creating running perforations at the positions we're going to be running the web over the plow fold heads. And we do the perforations not only to help control where the web is folding, but also to eliminate that saddle that you would get when you fold paper, because we need the book blocks to be perfectly flat and square. Otherwise, your spine art and things like that get messed up if the spine is thicker than it would be if you were just doing cut sheet book blocks.
Right.
What the StreamFolder lets us do is do one-off book blocks, because the impositions on the web are essentially in a slalom format instead of side-by-side. So on this 3-up web, pages 1 through 6 of the book go across the web, then 7 through 12, 13 through 18, and so forth. We fold each one of those up into a Z-fold configuration, sheet them from the web, accumulate them into a book block, glue them together, and then deliver that book block to the output conveyor.
Okay.
The other great feature that the StreamFolder has is what we call an auto setup option. So there are some measuring sensors inside that front door that you can't see. But if we tell it to run an auto setup, it will actually move those out and measure the exact size of the web down to the 1/10 of a millimeter. And then it will automatically position the fold heads, the perf heads, and everything based on the format that book's going to run. So it can account for web width variation from one roll to the next, even if it's a 1/16 of an inch or an 1/8 of an inch or any of those things.
Wow.
So it's great.
Pretty precise.
Yeah.
Yeah.
As you come out of the infeed where we create the perforations, you come up over the fold heads. You can see how stable the web is and how smooth it runs. Very quiet. The doors that have nip drives and things are interlocked. These 2 are not. So you can get a good picture of the web running over the heads. We manage the tension not only on the infeed and the outfeed, but through the middle of the machine. We can bypass one of the heads if you're doing a 2-up and only do a single fold. When we do a 3-up, we actually do a Z-fold. So on that first fold head, you see the backside third of the web get folded underneath. And then as you come to the second head, you see the front side third get folded up over it. We call it a Z-fold because when you look at that signature, it looks like a Z.
Yeah.
The reason we do that is because we know exactly where the fixed edge of the press is. We align to that same edge. We base it a third of the web from that, and then another third of the web, and we fold that into the Z pattern. Any variation you would see in that web width, whether it's due to climate conditions, variances from roll to roll, things like that, all ends up in the face side of the book. So when you 3-knife trim it and you take that face trim off, you get perfect spine alignment and all the variations out in the face. We're also gluing the signature closed in the StreamFolder. If you zoom in on there, you'll get that HHS glue head that we have, that we're controlling the glue dot size, the glue dot frequency. And what we're doing is we're closing that signature. We're then going to glue all the signatures together as part of the stacking process and give you an extremely solid, perfectly registered, well-jogged book block that's easy for the operators to handle that doesn't require any jogging before binding. So as you exit the StreamFolder, you've now got a 3-up folded web that's essentially 1 wide as it comes into the infeed of the C51 cutter. This is the C51 version of the Revolution 50 cutter platform, which means it's the single knife, because you're going to be perfect binding these, and then 3-knife trimming them after binding. We only need to do a single knife cut as opposed to a dual knife strip cut. So we come in here, we're looking at top of form registration that's going to determine our cut position. We're driving the web forward. Everything in here is center justified. So when you run different widths of paper or different fold formats, it's a very fast, easy changeover. We then come through the rotary knife assembly, which is sheeting the signature from the continuous folded web. Those signatures then advance through the aligner section and into the shingling section, where we're advancing them slowly. This shingling section is one of the things that lets us run this line extremely fast, up to 750 linear feet per minute, because when we're stacking, we've created a shingled stream, so we don't do lead edge damage, we don't get a lot of sheet bounce or signature bounce back that disturbs the stack. And then in addition, we come through here and you can see these oscillating side joggers that are squaring up the signatures into a continuous stream. And then you come into the gluing section where we're dropping glue in 3 of the corners of the book block. So in the StreamFolder, you'll recall we glued the signature closed. Now we're gluing the individual signatures into the book block. That book block then gets stacked, jogged both head and foot, in addition to spine and face. And then that stack comes out into the book press. What the book press does is it compresses the stack, it forces any air out of the folded signatures, it allows the glue to set under pressure, and then when that next stack comes out of the stacker and is ready to deliver, the one that's in the press advances up the conveyor. And we're also showing our RoboLoad cobot robot at this show. And what it does is it picks up the stack of book blocks and puts them onto a pallet. So we're going from either an inline solution with a digital press or a pre-printed roll of book block impressions, all the way to a stacked pallet with essentially no intervention for the formats that we're running.
So how new is the cobot edition on the back end here?
That's just been released this year. We showed it in Germany at Drupa, and this is the first time it's been shown in the US. So there is a stack of book blocks that's delivering up the conveyor. It'll go into the pickup module of the robot, it'll pick it up, it'll advance it over to the open spot on the pallet, and then set it down into a stack. And the robot remembers where it has stacked things, because as the day goes on, it'll actually do multiple stacks on top of those. In that stack of book blocks that you saw come up the conveyor, it's essentially a whole bunch of individual book blocks. And you can see how well registered this book block is. It's all held together. There's no way to disturb these signatures, so there is no jogging required by the operator when he goes to drop this book into a binder. It also gives us the ability to use an automated destacker. So if you have this stack of books and you bring it up a conveyor, you can open a destacking gate, push the bottom book, and it'll just take the bottom book off the stack and do that. So really easy for the operator to find the breakpoints in these book blocks, the way we've glued them together.
Great, fascinating stuff.
So that's the StreamFolder 5152 book block solution.
This is the first time this system is shown in North America, right?
Correct, yep. And all the solutions that are in the Tecnau booth will be going back to the Tecnau Demo Center in North Andover, where we'll bring customers in, we'll be able to run their papers, their pre-printed book block applications, demonstrate the capabilities for their applications.
Great, well Pete, we appreciate the overview.
Thanks very much.
Thanks, man.